Professor Howell could not be with you today, so he asked if I would come and talk to you about Fubini's theorem. As you see, I borrowed the telephone booth from the Doctor Who, and I traveled through time from a previous century. I had a bit of a problem though. The telephone booth door, also called the TARDIS door, is stuck, but there's an emergency button on the other side of the door. If I can pound through and put a hole in the wall with this board, then I can reach through, press the button, the door will open and let me out. One moment, please. It is a bit of a stubborn door, but I think this next one will do it. Okay. No, not there. I try a little lower. Ah, yes. Here it is. I press the button.
That was easy.
Yes, that was easy. Okay. Now I do come and talk to you about Fubini's theorem, which I'm honored to say is named after me because I proved the theorem in 1907. In order to talk to you about it, all I have to do is come in, 2, 3, classroom.
Previous century to hear Dr. Howell tell me you were a very good class, and this is going to be a very critical class because we are going to learn how to do the integrals for multivariable functions. So, you do not know the Guido Fubini, right? And so I'm going to tell you a little bit about myself. Guess what nationality I am? Yes. And I was born in Venice. Then I go to school at the Scuola Norme Superiore. Can you say that? There is the crest, and that is in Pisa. I get my PhD in 19, just as the last sentence. And then I begin teaching at the University of Campanile, which is down here. Now, this is a okay university. It's not the best. But it's a good university. I'm happy to be there. I proved this theorem in 1907. And then I get famous. I become famous. And so I get an offer to teach at University of Turin, which is more prestigious. I go there. It's more of a metropolitan area, as you see, near Milan, near the, I like to ski, there are the Alps from Switzerland and Italy, and it's just very much fun. Then something happened in 1939 that made me leave to the US. What do you think that is?
World War II.
Yeah, why do you think I leave? Oh, and let me tell you something. I am Jewish. Why do you think I leave? Because
Italy was the Axis power.
so who is the bad guy? Well, yes, he's a bad guy, but not in Italy. Mussolini, right? Bad guy. So I leave there, and so that's where I am now. That's where I come to. I did not know this. So when I go back in the telephone booth, I think I will go back to my happiest time, 1908. So I sort of died in 1943. I do not have much time. Now, what does Fubini say? Well, let's talk a little bit about doing the integrals. So I think you know how Dr. Hooley told me, what do you call these, the baby calculus? So you know how the integrals work. How do you get them? So yeah, you think of it as area under the curve, right? And what you do is you have some sort of a function. Now I'm not drawing the same thing. You have a, and you call that x0, and you have x1, x2, x3, you call that e. And somewhere in the middle you have xi minus 1, xi. Yes? And then you pick a point somewhere in the middle. That's what we have here. So in this example, x sub 1 star is the number 1. X sub 2 star is the number 3. X sub 3 star is the number 5, and so on. And you see, okay, how high is the function at that point? And the function is 2. And you make that rectangle, yes? And what is the area of that rectangle?
Sub I minus x, sub I minus 1.
Exactly. Dr. Hu will tell me you're very good students, so I'm not supposed to. All right, these abbreviation for these.
Delta.
Now, what does this represent geometrically?
Rectangle area.
Now, let me just tell you, you give any baby calculus student that problem. I promise you they cannot do it. I promise. Why? Because you can prove there is no antiderivative of e to the minus x squared. You can prove at least one that you could write with simple functions. But we are going to. We will confuse. Guido Fubini, he must go back to the 1908. But we will compute this next week using, believe it or not, what?
Substitution. Double integral. Double integral.
What theorem?
Fubini's
theorem. Yes.
Where you go?
I actually got back there just waiting for all of us.
Yeah, no, it's like Dr. Howell just walks out of there.
Oh, hello. I am Guido Fubini.
Cut. Fubini, not Houdini.
Fubini. As you see, I borrowed the
Cut. Take off the glasses.
glasses. As you see, I'm calling from the telephone booth from the
Cut.
doc.
As you can see, I borrowed the telephone booth.
Borrowed the telephone booth. Okay. As you see, I borrowed the telephone book from the Doctor
Cut.
Who.
Booth, not book.
Telephone booth. As you see, I borrowed the telephone in the booth. As you see, I borrowed the telephone book from the Doctor Who.
Cut. The board is visible.
Oh, the board is visible.
Cut.
Oh my god. But